ChatGPT, and welcome to the Bare Metal Cyber CISSP Prepcast. This series helps you prepare for the ISC Squared CISSP exam with focused explanations and practical context. In this episode, we are going to explore two important access control mechanisms that are part of fundamental cybersecurity design. These are access control lists and capability tables. Both of these mechanisms are ways to manage and enforce who gets to access what resources in a system. They help organizations define and enforce security rules, particularly when it comes to who is allowed to perform actions like reading, writing, or executing files or accessing systems or services. While they are not the only methods of controlling access, they are among the most common, and you will likely encounter questions about them on the certification exam. Understanding how each of these models works, where they are used, and what their strengths and weaknesses are will help you make better choices when designing or evaluating access control policies. Let us start with access control lists. An access control list is essentially a table or a list that is attached to an object, such as a file folder or even a network device. That list contains entries that specify which users or systems can perform which actions on that object. These actions usually include things like reading, writing, modifying, or executing the object. Each entry in the list defines a subject and the permissions that subject has over the object. For example, you might have a file that has an access control list attached to it, and the list says that user A can read and write the file, user B can only read it, and user C is denied all access. That list directly controls how each user can interact with the file. Access control lists are widely used in many different systems. They are common in operating systems like Windows and Linux. They are also used in network devices like routers and firewalls. In those devices, access control lists help define which types of traffic are allowed to enter or leave a network segment. For instance, you might have an access control list on a router that blocks all incoming traffic from a particular IP address, or that only allows outbound traffic to specific ports. In that context, the access control list is not managing users, but instead managing network flows. Despite this difference, the core concept remains the same. You have a list, and the list determines what is allowed and what is not. One of the benefits of access control lists is that they are relatively easy to understand and administer in smaller environments. They allow for fine-grained control over resources. An administrator can give one person access to perform a specific action while denying that same action to another person. This level of detail helps enforce the principle of least privilege, which says users should only have access to the resources they need to perform their job. But as environments grow more complex, access control lists can become harder to manage. If you have thousands of users and hundreds of files, each with its own access control list, then managing and auditing those lists can become a challenge. It becomes more likely that a user will receive access they should not have, or that a change will be missed during a routine update. Another limitation of access control lists is that they are object-focused. This means the control is attached to the object rather than the user. If you want to know what a particular user can access, you have to check all the objects and review their access control lists. That process is inefficient and can be difficult to scale. In larger environments, this can lead to performance issues and increased administrative overhead. It also makes it harder to audit user access across the entire system. Now let us turn to capability tables. A capability table is another method of defining access control, but it takes a different approach. Instead of attaching a list to an object, a capability table focuses on the subject. Each user or process has their own capability table, which lists all the objects they can access and what actions they are allowed to perform. Think of it as a personalized list of permissions. For example, if you are user D, your capability table might say that you can read file 1, write to file 2, and execute file 3. That table travels with you, and the system checks it when you attempt to perform an action. The benefit of this approach is that it is easier to audit and understand what a user can do across the system. Rather than checking every object to see if a user has access, you can simply review the user's capability table. This is especially helpful in distributed environments where users might need to interact with many different resources spread across various systems. Because the capability table is user-focused, it aligns well with identity management systems that are designed to grant permissions based on user roles and attributes. However, capability tables are not without challenges. Managing these tables for large numbers of users can be complex. If permissions change frequently or if users change roles often, then the tables must be updated regularly to reflect those changes. There is also the question of how to securely store and manage the tables themselves. If an attacker gains access to a user's capability table, they might be able to escalate privileges or perform unauthorized action. This makes it essential to combine capability tables with other security mechanisms like strong authentication and encryption. Both access control lists and capability tables are part of discretionary access control systems. In discretionary access control, the resource owner or system administrator has the ability to decide who is allowed to access what. This is in contrast to mandatory access control, where access decisions are enforced by the system according to fixed rules and users cannot override those rules. Understanding this distinction is important for the certification exam. You should be able to identify whether an access model is discretionary, mandatory, or role-based, and know the strengths and weaknesses of each. In practical terms, organizations often use a combination of access control lists and capability tables depending on the system and the specific use case. For example, a file system might use access control lists to determine who can open or edit files, while a networked application might use a capability table to track what resources a user can access based on their login credential. The key is to ensure that access control policies are clearly defined, consistently enforced, and regularly reviewed. Now is a good time to take a short break and point you toward additional learning materials. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. As we return, let us look at how to implement and manage access control lists and capability tables effectively. The first step is to define clear access control policies. These policies should specify which users or roles are allowed to perform which actions on which resources. Whether you are using access control lists or capability tables, the rules must be unambiguous and aligned with business objectives. Policies should be reviewed regularly to ensure they reflect current organizational needs, especially as users change roles or leave the organization. Next, you need to establish procedures for assigning, reviewing, and revoking access. For access control lists, this means regularly reviewing the lists attached to resources and updating them as needed. For capability tables, it means reviewing each user's capabilities and ensuring they match their job responsibilities. Automation can help with these tasks. Many identity and access management systems offer tools to automate permission reviews, generate audit reports, and enforce policies based on predefined rules. Monitoring is also a critical part of access control management. It is important to have visibility into who is accessing what, when, and how. Logging access events and reviewing those logs regularly can help you detect unauthorized activity, policy violations, or system misuse. Alerts should be configured to notify administrators of unusual access patterns, such as a user accessing sensitive files outside of normal hours or from an unexpected location. Training plays an important role in maintaining secure access control. Users must understand their responsibilities when it comes to accessing resources. They should be educated about the importance of following access control policies, using strong credentials, and reporting any issues they encounter. Likewise, administrators must be trained to configure and manage access control lists and capability tables correctly, ensuring the system is both secure and efficient. Access control is not a one-time setup. It requires ongoing effort, regular updates, and careful oversight. As threats evolve and organizational structures change, access control systems must be updated to remain effective. This includes adjusting permissions, updating policies, and deploying new tools as needed. By staying proactive, you can reduce the risk of security breaches and ensure that only authorized users have access to sensitive information and systems. In closing, Access control lists and capability tables are both valid and useful tools for managing access to resources. Each has its strengths and weaknesses, and your choice will depend on the specific needs of your organization and the context in which they are used. The key is to understand how each method works, what kinds of systems they are best suited for, and how to manage them in a secure, scalable way. For the CISSP exam, be sure you can explain how access control lists differ from capability tables, identify which model is being used in a given scenario, and evaluate the effectiveness of each approach in supporting security principles like least privilege, accountability, and confidentiality. Thanks for joining us for this episode of the Bare Metal Cyber CISSP Prepcast. For more episodes, tools, and study support, visit us at baremetalcyber.com.